Good day everyone, this is Sir Fred and welcome to another video lesson tutorial. In today's lesson, I'm going to discuss finding measures of position using the general method. Let's get to know the following objectives. Illustrate the following measures of position for ungrouped data, quartiles, deciles, and percentiles. Second, compute the quartiles, deciles, and percentiles of ungrouped data using the general method. And finally, interpret measures of position for ungrouped data. Let's get started. Let us first define what are measures of position. When we say measures of position, these are various techniques that are used to divide the data into equal groups. Statistical data arranged in either ascending or descending order and can be divided into various parts. Next term to define are ungrouped data. When we say ungrouped data, these are raw data and that has been collected but not sorted into any group or classes. These are data given as individual points such as values and numbers, examples of which are 23, 20, 13, 12, 10, 9, and so on. To highlight the main discussion for today, our focus are all about measures of position for ungrouped data. These are quartiles, deciles, and percentiles. Take note, class, that the idea of the median can be associated with the concepts of quartiles, deciles, and percentiles. What are quartiles? When we say quartiles, these are score points which divide a distribution into 4 equal parts. By taking a look at the representation, consider this as score points. If we want to divide this distribution into 4 equal groups, we will divide it by 3. The first partition is what we call the lower quartile, represented as Q sub 1. The second partition is the median, or quartile 2, or Q sub 2. And lastly, the last partition is named as the upper quartile, or Q sub 3. It also means that 25% of the distribution is less than or equal to the first quartile. Second, 50% is less than or equal to the second quartile. And last but not the least, 75% of the distribution is less than or equal to the third quartile. One thing to remember about the concept of quartiles is the interquartile range. When we say interquartile range, it is the difference between Q sub 3 and Q sub 1. It gives the measure of the spread around the center of the data. It tells where you find the middle 50% of the data. The second measure of position are deciles. When we say deciles, these are 9 score values that divide a distribution into 10 equal parts. So class, If we want to divide this distribution into 10 equal parts, we need to divide this by 9. Each of the partition has its name, namely D sub 1, D sub 2, D sub 3, D sub 4, D sub 5, D sub 6, D sub 7, D sub 8, and D sub 9. This means that 10% of the data has a value less than or equal to D sub 1, 20% of the data has a value less than or equal to D sub 2, 30% of the data has a value less than or equal to D sub 3, and so on, until you reach 90% of the data has a value less than or equal to D sub 9. Take note also that D sub 5 is considered to be the median of the measure of position. And also, D sub 5 is also equal to quartile 2. The last measure of position is what we call the percentiles. Percentiles are the 99 score points which divide a set of data in 100 equal parts. Percentile is the most commonly used measure to determine the standing of an individual in a group. By looking at the illustration, we can say that 25% of the data has a value less than or equal to P sub 25, 50% of the data has a value less than or equal to P sub 50, and 75% of the data has a value less than or equal to P sub 75. Until you reach 99% of the data has a value less than or equal to P sub 99. And also, remember the following equality. Quartile 1 is equal to percentile 25. Quartile 2 is equal to the 50th percentile. And quartile 3 is equal to the 75th percentile. In solving measures of position for ungrouped data, we have the following methods. First, we have the general method. Second, we have the Mendenhall and Sinsich method. And last but not the least, linear interpolation method. For our discussion for today, our main focus is finding the measures of position using the general method. Here are the following formulas that you need to remember in solving measures of position using the general method. For quartiles, we have Q sub k is equal to k times n all over 4. For deciles, we have d sub k is equal to k times n all over 10. For percentiles, we have p sub k is equal to k times n all over 100, wherein k is equal to the position of the data or index, and n is equal to the number of position. Here are the steps in finding quartile, decile, and percentile in ungrouped data. First step is for us to arrange the data in ascending order. Second, find the rank using the formula for quartiles, deciles, and percentiles. And number 3, determine the quartile, decile, and percentile value. Okay class, take note of the following. Upon using the formula for quartile, decile, and percentile, if the quotient obtained is not a whole number, round to the next larger whole number. Starting at the lowest data value, count to the number that correspond to the rounded up value. And also, if the quotient obtained is a whole number, use the halfway between the position of k times n over 4 and kn over 4 plus 1 value when counting up from the lowest value. Let us take a look at this example. Consider the set of scores in a quiz in Math 10. The results were 14, 10, 12, 9, 17, 5, 8, 9, 14, 10, and 11. Find the lower quartile, second quartile, and upper quartile of the data. So first thing to do is for us to identify the value of the lower quartile. In our first step, we need to rank the data in ascending order. We have 5, 8, 9, 9, 10, 10, 11, 12, 14, 15, and 17. In our second step, locate the position of quartile 1 using the formula k times n all over 4. As we all know, class, that k here corresponds to the quartile that we are looking for. So since we are looking for quartile 1, so we have here 1 for k times the total number of data in the problem, that is 11, divided by 4. So multiplying 1 times 11 divided by 4 results to 2.75. According to the rule, we need to round it up, and therefore, the value of the lower quartile is in the third position, and by counting from left to right, so we have 1, 2, and 3, the value of quartile 1 is equal to 9. So therefore, it means that 25% of the scores are less than or equal to 9, while 75% of the scores are greater than or equal to 9. The next value that we need to identify is the value of the second quartile. So since we have ranked up the data, so let's proceed to the second step, and that is to locate the position of quartile 2 using the formula k times n over 4. So we have 2 times 11 all over 4. So the reason why we use 2 here is because the quartile that we are looking for is the value of quartile 2. So multiplying 2 times 11 is equal to 22 divided by 4, that is equal to 5.5. And according to the rule, we need to round it up, and the value of quartile 2 is in the 6th position. So what are we going to do, class, is to count from left to right. So we have 1, 2, 3, 4, 5, and 6. So therefore, the value of quartile 2 is equal to 10. It means that 50% of the scores are less than or equal to 10. And for the final unknown in the problem is the upper quartile. We have ranked the data, and let's proceed to the second step and locate the position of quartile 3 using the formula k times n over 4. By substituting the values, we have k, which is equal to 3 times 11 divided by 4. That is equal to 33 over 4. So that is equal to 8.25, and according to the rule, we need to round it off, and the quartile 3 in the set of data is located in the 9th position. So we need to count 1, 2, 3, 4, 5, 6, 7, 8, and 9. So therefore, quartile 3 is equal to 14. It only means that 75% of the scores are less than or equal to 14, while 25% of the scores are greater than or equal to 40. Let's have another example. Find the quartile 1, the median and upper quartile, and the interquartile range of the given data. We have 19, 13, 3, 10, 15, 20, 18, 10, 12, 13, 16, and 17. Our first step is to arrange the data in ascending order, resulting to 3, 10, 10, 12, 13, 13, 15, 16, 17, 18, 19, and 20. So first thing to solve is the value of quartile 1. Using the formula, Q sub k is equal to k times n all over 4. Substituting the values for k, which is equal to 1, the total number of data is equal to 12 divided by 4. 1 times 12 is equal to 12 divided by 4. That is equal to 3. According to the rule, if the quotient that we have identified or found out is a whole number, so therefore what are we going to do is to get the average of the two positions consecutively. So we have the third and the fourth position. So we have 10 plus 12 divided by 2. The value of quartile 1 is equal to 11. The next value that we need to identify is the value of the median, or that is quartile 2. So by substituting the values in our formula, we have 2 times 12 divided by 4. That is equal to 24 divided by 4, and the result is equal to 6. Just like in our quartile 1, we have found out that the value is a whole number, so therefore we are going to get the average of the 6th and the 7th position. So we have 13 plus 15 divided by 2. The value of quartile 2 is equal to 14. Last but not the least is the value of the upper quartile, or quartile 3. So we have 3 times 12 divided by 4. 3 times 12 is equal to 36 divided by 4. That is equal to 9. Since it is a whole number, just like in quartile 1 and quartile 2, we are going to get the average of these two positions, which is 9 and the 10th position. So we have 17 plus 18 divided by 2. The value of quartile 3 is equal to 17.5. Last but not the least, class, is for us to identify the value of the interquartile range. So we have the value of the quartile 3 minus the value of quartile 1. So we have 17.5 minus 11, that is equal to 6.5. So therefore, our interquartile range is equal to 6.5. For our third example, the scores of 12 students are as follows: 15, 13, 20, 16, 14, 19, 15, 19, 11, 10, 18, and 9. So first, we are going to identify the value of d sub 1, followed by d sub 4, and last but not the least is the value of d sub 9. So first thing to do is to arrange the data in ascending order as presented on your screen. And next thing to do is for us to identify the value of the decile 1 using the formula k sub n all over 10. By substituting the values, we have d sub 1, which is equal to 1 times 12 all over 10, that is equal to 12 over 10. And the value is equal to 1.2. According to the rule, we are going to round it up in the next position, and that is equal to the second position. So therefore, the value of our decile 1 is equal to 10. The next thing to identify is the value of the fourth decile. So we have 4 times 12 all over 10, and that is equal to 48 all over 10. So 48 over 10 is equal to 4.8, and of course, according to the rule, we need to round it off. So that is equal to the fifth position. So by counting, the fifth position in this set of data is equal to 14. So therefore, the value of the fourth decile is equal to 14. Last but not the least is to identify the value of the ninth decile. By using the formula, we have 9 times 12 all over 10, that is equal to 108 all over 10. So 108 divided by 10 is equal to 10.8, and of course we need to round it up according to the rule, that is equal to the 11th position. By counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, the value of the ninth decile is equal to 19. For letter B, using the same problem, show that d sub 5 is equal to quartile 2. So first thing to do, class, is for us to arrange the data in ascending order. And of course, we are going to use the following formulas for quartile and decile. So first thing to do is for us to identify the value of the fifth decile. So we have 5 times 12 divided by 10. So 5 times 12 is equal to 60 divided by 10, that is equal to 6. Since it is a whole number, we are going to get the average of the 6th and the 7th position. So that is 15 plus 15 divided by 2, the value of the fifth decile is equal to 15. And last but not the least, we are going to identify the value of quartile 2. So we have 2 times 12 divided by 4, that is equal to 24 over 4, and that is equal to 6. Since it is a whole number, we are going to get the average of the 6th and the 7th position. By counting, we have 15 for the 6th position and 15 for the 7th position divided by 2. The value of quartile 2 is equal to 15. So therefore, as what you can see, class, the value of the fifth decile that we have solved is equal to the value of quartile 2. So therefore, we can conclude that the value of the fifth decile is equal to the value of quartile 2. For example number 4, the score of 12 students are as follows: 15, 13, 20, 16, 14, 19, 15, 19, 11, 10, 18, and 9. So what are we going to solve first is to identify the value of the 40th percentile and the 65th percentile. So we are going to arrange the data as what you can see on your screen, and afterwards we are going to use the formula for the percentile, that is equal to P sub k equals k times n all over 100. Of course, we are going to substitute the value of the 40th percentile as well as the 65th percentile based on the problem. So for the 40th percentile, we have 40 times 12 all over 100. And for the 65th percentile, we have 65 times 12 all over 100. Okay, so we have 480 all over 100. And for the 65th, we have 780 all over 100. So what we have found out for the 40th percentile, that is equal to 4.8. So by rounding up, according to the rule, so the value of the 40th percentile is located in the 5th position. By counting, we have 1, 2, 3, 4, and 5. So therefore, the 40th percentile here is equal to 14. While on the other side, so what we have found out, when we divide 780 over 100, we have 7.8. Rounding up, according to the rule, we have the 8th position. By counting 1, 2, 3, 4, 5, 6, 7, and 8, the value of the 65th percentile is equal to 16. For letter B, using the same problem, we are going to show that 75th percentile is equal to quartile 3. So first, we are going to arrange the data in ascending order, and afterwards apply the formula for quartile and percentile. So for quartile 3, we have 3 times 12 all over 4, that is equal to 36 over 4. And for 75th percentile, we have 75 times 12 all over 100, that is equal to 900 all over 100. That results to 9 for quartile 3, the same as 9 for the 75th percentile. But since both of them has a quotient which is a whole number, we're going to get the average of these two positions. So we have the 9th and the 10th position. By counting, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have here the value which are 18 plus 19 divided by 2. So both of them results to the same answer, which is 18.5. So therefore, we can conclude that the value of the third quartile is equal to the value of the 75th percentile. And for our last and final example, consider the given data: 120, 145, 181, 188, 191, 200, 211, 228, 230, 232, 243, 257, 258, 259, 272, 275, 278, and 300. Find the percentile rank of 191. Of course, just like what it is mentioned in our first step, we are going to arrange this data in ascending order as what you can see on your screens. And of course, since we are finding for the percentile rank of a given data, so we are going to use the formula: the number of values below or equal to the given value divided by the total number of values times 100. So we have the number of values below 191 is 5. So that is 120, 145, 181, 188, and also together with 191 all over the total number of values, which is 18 times 100, which results to, of course, we have 0.2777778 times 100, okay, that is equal to 28. So take note, class, that percentile ranks are always expressed as whole numbers. So therefore, it only shows that 28% of the numbers in the data set have values less than or equal to 191. To summarize the things that we need to remember for today's topic, which is all about the measures of position, measures of positions are determined by dividing the given data into parts. In quartiles, we divide the ranked data into 4 parts and locate in what part a certain score is. We may also divide a given set of data into 10 parts. We call this as deciles. The value that divide a rank ordered set into 100 equal parts are called percentiles. The formula for finding the quartile rank is Q sub k is equal to k times n all over 4. The formula for finding the decile rank is equal to d sub k, which is equal to k times n over 10. And finally, the formula for finding the percentile rank is equal to p sub k, which is equal to k times n all over 100. If the quotient obtained is a whole number, use the value halfway between the positions of the k and the k plus 1 value. If not, find the next larger whole number. And by that, thank you very much and have a great day, and God bless us all.